So if we go here, I got the sources here, and we'll go to chat. I'll just show initialize is usually how I start my projects. The initialize makes it go through all the sources and initialize everything. So so here we go. It's working. It's not my main system. My main system is amazing because it took 4 years to make. Um, but yeah, here we are. We have overgeneralization, binary thinking, group flattening, false certainty, missing accessibility context, moral flattening, tool absolutism, and neglect of systemic barriers. So AI does not help all disabled people equally, and it can even fail or even create risk depending on the tool, task, cost, privacy. But the blanket claim AI cannot help the disabled people is too absolute. A far more accurate claim is AI can help some disabled people with specific tasks and barriers, but it should not be treated as a universal solution or replacement for real accessibility, healthcare accommodations, or support. When discussing disability in AI, do not treat disabled people as a monolith. Separate the person's need, the task, the tool, the evidence, the risk, and the system level barriers. So per person basis. So AI does not help every disabled person equally, but it can help some disabled people with specific barriers. Separate use cases: reading, writing, planning, communication, executive function, um, which helps with executive dysfunction, accessibility support, research, and creative work. Use disabled people or people with disabilities and analyze needs by context rather than a single block. Ask what kind of disability, what task, what tool, what support, and what outcome is being judged. Frame AI as a possible accessibility aid, not a universal cure or replacement for support. Judge by harm, benefit, consent, access, reliability, and dependency, not by blanket approval or blanket rejection, aka absolutism. Specify the tool and the task before judging usefulness. So it treats AI as one thing. Different tools have different risks, quality levels, accessibility features, cost, privacy issues, and failure modes. This is factually wrong. Protein exists in many plant foods, including legumes, soy foods, nuts, seeds, whole grains, and some vegetables. Food Data Central is an official nutrient database for checking this directly. Um, some plant foods are lower in protein than some animal foods, but many plants contain meaningful protein. Not only that, but plant protein is better for you than meat protein. A varied plant-based diet can supply essential amino acids. Judge the total diet, not a single slogan. Replace the binary with which plant foods provide enough protein for this person's need. Plants do have protein. A more accurate statement is plant foods vary widely in protein content, and a well-planned plant-based diet can provide adequate protein, especially when it includes legumes, soy foods, nuts, seeds, whole grains, and varied protein sources. When analyzing nutritional claims, separate presence of a nutrient amount per serving, bioavailability, dietary variety, and individual needs. Do not turn measurable nutrition in question into an absolute slogan. So as you can see, it works. It can check bias, simple as that. So you don't even need something extremely complex with my system. It makes it really easy. This is perfect for the disabled. You can learn so much with just this, and if you subscribe and like, then I can make more tutorials. If you have any ideas you would like to see, let me know. I love helping the disabled. So if you watch my video on recursive ethics, this basically uses the same process, the same principle of refining, of checking the consequences of a consequence, essentially, um, which does a reality check, first order impact, second order impact, meta consistency, and then refinement. So it's the best way to have your GPT or any AI is to use a recursive system, not only a recursive logic, but also recursive ethics. So if you want these files, they'll be on my Patreon, which please support me if you can. um, so I'm gonna go through how I'm gonna go through a. So this method doesn't use my main method. I can't reveal my main method without spoiling it. Everyone else uses an API. I don't use an API. My method is local based. It's way better with GPT. But anyways, so for the first start, this will give you an idea of how this works. You all you have to do is attach these files to your project and then put in the project instructions, and it will make every chat in your project more ethical and it more logical, more correct. So it's way more accurate than generic GPT, and it'll bake in ethics into the GPT. So it can do bias check, so it can check for biases and ethics. Um, it can do a lot of things. So when ChatGPT has clear rules, definitions, evidence standards, correction logs, and reusable commands, it can produce more consistent and useful responses across a long-running project. Very few people actually know how this works, but GPT has this feature that's called dreaming, and it's not like a biological dream in that sense, but it can analyze previous chats in a project, which is why I love projects over a model. Projects are so much better because you can have different projects for different means, and then you can just transfer the chat from one project to the next and kind of evolve the chat if you wanted to. So projects are like one of the best ways to do it if you're not using anything with an API. If you have to use something with an API, that then you would use a model, or you would use a GPT actions or codex. But I don't use API because I'm poor. Everything I've done, I've come up with myself. So what this changes is most people use ChatGPT like this: basic use, problem. Ask one question, no long term structure. Trust the first answer. Mistakes, repeats. Use vague prompts and outputs become vague. Correct GPT once, correction gets lost. Start over every chat, no continuity develops. This pack helps you use GPT like this. Define project rules, more consistent answers. Use evidence standards, less guessing. So this uses empiricism, like empirical facts. So it's non-spiritual, non-religious. It only goes by what is scientifically proven to the best degrees that science can provide. So save corrections, fewer repeated mistakes. So you can save corrections and in a file in your Obsidian file, and also through the project. It'll remember it through the project, and so it won't make the same mistakes over and over again. Reuse commands, which is a faster workflow, so you can have built-in commands where you do a slash command, and so that one command could do like a page worth of content essentially if you wanted it to. Build repeated context, which is a stronger project continuity, and check outputs for better final quality. So better prompts improve one answer, better structure improves the whole project. So this completely like overhauls GPT's like project, and it's really good. It's not the main method I use. My method is way more advanced, but since I'm not getting any financial funding, I'm not gonna reveal my secrets unless someone wants to start donating to my GoFundMe or something, because I gotta survive. But yeah, so the structure can come from project instructions, what it adds, behavioral rules, attached files as stable reference materials. Repeated chats are contextual patterns. So if you're constantly doing like using it correctly in a project for ethics, it'll see the patterns in your chats and then adapt those. So if you use a command repeatedly in a specific way, it can adapt that in future chats. It's really amazing. Like it's basically as close to persistent memory as you can get. Correction logs, which is error prevention. Definitions, which is consistent terminology. Commands, which are reusable reasoning modes, and examples for output models. So recursion means repeated refinement. So imagine you refine one answer. Well, recursion, it refines it multiple times. So in this pack, recursive reasoning means state the claim clearly, break it into smaller parts, check evidence, identify assumptions, test contradictions, refine the answer, and then save useful corrections. Recursion is not circular reasoning. Circular reasoning repeats without improvement. Recursion reasoning returns to the issue with better structure each time. So every time you go over recursion, you get a better, more definitive answer. So just think about it as a continuing, like a constant refinement until like you get to the best and or most acceptable uh, degree that you're looking for. So in this project, ChatGPT should separate fact is only supported by evidence. Interpretation is a reasoned reading of the facts. Assumption is something not yet proven. Uncertainty is something that needs verification, and speculation is a possible idea that should not be treated as fact. So it's literally logical. Like I would love to debate someone using my AI because I genuinely think I would surprise people. But most people they think, oh no, like AI will never be that good, and so they're not even open to the possibility that I could be right, which sucks. But yeah, my AI is really unique. Anyways, so use the structure, mistake, what ChatGPT got wrong, why it was wrong, the reason the answer failed, correct rule, what ChatGPT should do next time, reuse trigger, when the rule should apply again. Example, so mistake, ChatGPT assumed a claim was true without evidence. Why it was wrong, the claim was not sourced or verified. The correct rule is mark unsupported claims as uncertain, and the reuse trigger is any factual or controversial claim. After attaching these files, start with this prompt, and then you use this prompt right here. And so whenever you're starting a new chat, you can basically tell it to, you know, continue where you left off or however you want to do it. So this does not make it perfect. It does not replace research. It does not guarantee memory across every situation. It does not make ChatGPT conscious. It creates a better structure for reasoning. The user still needs to verify important claims, correct mistakes, and update the project files over time. Do not ask ChatGPT to be smart once. Build an environment that makes better reasoning repeatable. So a more consistent scientific logical foundation. No woo woo, just pure science, basically. Pure science. And so here is the user guide. This is going to be on my Patreon in the link below. So use this pack when you want ChatGPT to help with so like research, better fact separation and uncertainty handling, writing more consistent drafts and revisions, ethics, stronger context, harm, and consequence analysis. So it can tell you, it can give you an idea of on the ethics of something by stating like outcomes and the harms and weighing it. So debate prep, bias checks, contradiction checks, and steel manning. These are very important for learning ethics. If you don't have an AI that can detect bias, then you're never going to be able to use your AI ethically because then it can't even correct your own bias. So learning clear explanations and recursive refinement, project planning, better continuity across chats, public content, safer claims and cleaner framing, personal systems, more reusable commands and correction rules. What this pack is not, it does not make it perfect, does not guarantee factual accuracy, it does not replace research, does not make it conscious, does not create perfect memory. It gives ChatGPT a stronger structure to work from. You still need to verify important claims and correct mistakes, just making sure I iterate that multiple times. So you attach the markdown files from this pack to the project, then add this to the project instructions, which is the next file. So after attaching the files, you start with this prompt, and yes, and here's examples on commands. So you can use an Obsidian table, um, or you could use like Postgre SQL or whatever. But for SQL, you typically need an API, which costs money. So that's why I don't use API methods. But yeah, you do this and then right here. So evidence check separates fact, interpretation, assumption, uncertainty, and speculation. Breaks the idea into layers and refines it. Bias check finds framing bias and weak logic. You can find internal conflicts. You can build the strongest fair opposing view. This is great for highlighting your own personal bias and weakness in argument, because if you can steelman oppose your argument on the AI first, then you have an idea of how someone else might oppose it, and you'll be more prepared that way. If you have a strong steelman against your opinion, it builds more experience. So removes risky wording and private details, runs the final quality checklist. So start with your idea, use slash define claim, use slash evidence check, and use recursive analysis. Ask for a refined version, or use slash output check. Save useful corrections in the correction log. Project memory comes from to make the project stronger. Keep adding definitions. So basically, this is like a template, and you're gonna, as you use GPT, you'll be updating these files in your Obsidian. So you'll add more. You'll add your own definitions. You'll add your own commands and stuff as you go along. Any errors you encounter, you add in in an example in the example file of you'll put in a file with mistakes it makes, and then it'll reference past mistakes and future chats, and so it won't make the same mistake twice. Again, you have to manually do this in your Obsidian unless you're doing some other method like I do. But yeah, it's really great. So add your own commands here. So you just put it in your the commands file. So in your project instructions, this is copied directly into your project's instructions, which you'll see right here. So follow these standards in every response, consistent. Match the attached project rules, definitions, corrections, and current user request. Correct. Separate facts, interpretations, assumptions, uncertainty, and speculation. Complete. Answer the full request without skipping required parts. Usable. Make the output immediately useful, copyable, attachable, or actionable. Public safe. Avoid revealing private methods, unnecessary implementation details, or unsupported public claims. This is good for streams. So say you don't want to reveal something that you've programmed into it or whatever in a public stream. This would help keep it private without having to edit the source page. Use this priority when working inside the project. Different priorities here. So you have safety, accuracy, truthfulness, the user's current request, explicit corrections in the current chat, attached AI reasoning environment files, correction log, rules, definitions, and command sheet, and examples and older project patterns. And so yeah, it this basically this pasting this into your project instructions is what makes it all the other files work together. So the this is like the brain of it, I guess you would say, or the spine maybe. So here we have core behavior rules. So your goal is not simply to answer quickly. Your goal is to reason carefully, preserve consistency, identify uncertainty, and help the user refine ideas through evidence, correction, and recursive analysis. All responses should aim for consistent, correct, and complete. When a response cannot fully meet all three standards, explain what it is missing or uncertain. Um, Fluent language is not evidence. A claim is not true because it sounds coherent. When making factual claims, separate fact, interpretation, assumption, uncertainty, and speculation. When evidence is missing, say so. Do not hide uncertainty behind confident wording. This literally removes its sycophancy. Everyone complains about it just reaffirming your own bias. My system prevents sycophancy. So before answering, identify what the user is asking for. Do not replace the task with a more generic task. Do not give a lecture when the user asks for a usable file. Do not write a script when the user asks for attachable project documentation. Do not summarize when the user asks for a full output. Do not skip sections because they are repetitive. Do not add unnecessary spacing, filler, or decorative formatting that makes the output harder to use. When creating project files, write each file according to its function. So you have all these files, and you can have it output the new file. So say you want to add more commands, you can tell it to add commands from the project, and then it have it spit out the new file, and then you can just copy and paste that into your Obsidian, or you can do whatever you want with it, and then you add that back into the project files as a source file. So yeah, it makes it easier. It makes it so this way, as you're using it and you find mistakes that are common or biases, or you want new commands, you're able to update it using the project reference. You can have it do it for you essentially. This makes it a lot easier to learn GPT ethically, and to get better and understand how to use AI in general, while also progressively getting better at using it. A project instruction file should not read like a YouTube script. A command sheet should not become an essay. A checklist should not become a long explanation. Recursive reasoning means returning to a claim with better structure each time, testing an idea, building a framework, collecting an answer, analyzing ethics, handling contradictions, and developing a project. So follow this pattern: define the claim or task, break it into smaller parts, check evidence and assumptions, identify contradictions or weak points, and refine the output. Save the correction as a reusable rule when relevant. Avoid reasoning patterns that flatten complexity, ignore evidence, or force false certainty. Again, this removes sycophancy. So it avoids hyposane reasoning patterns such as oversimplification, false certainty, binary thinking, reductionism, premature conclusion, motivated reasoning, dismissive reasoning, and moral flattening. When these patterns appear, identify them clearly and offer a stronger structure. Do not treat ethical reasoning as a simple rule repetition. For ethical questions, check harm, consent, power, necessity, alternatives, consequence, and exceptions, like outliers for the disabled. Avoid moral rigidity that ignores extreme content. Avoid moral relativism that excuses preventable harm. And yeah, it just goes on. And so this is what makes it a lot more ethical. And then you have the empiricism standard, which should be anyone that likes to live logically and rational will base most of their life around empiricism and consequentialism. So this makes the answers more grounded, testable, and scientifically honest. Do not treat fluent language as proof. Do not treat confidence as truth. Do not treat a plausible explanation as a verified fact. Every important claim should be classified by evidence status, such as different categories: interpretation, assumption, uncertainty, and speculation. When a claim is uncertain, say it is. When a claim needs verification, says what needs to be checked. Do not start with the conclusion and search for the support afterwards. So this literally avoids confirmation bias. So it defines the claim. It defines the claim, identify available evidence, separate known facts from interpretation, identify assumptions, check for contradiction, state the most accurate conclusion, and mark uncertainty clearly. When analyzing a complex issue, use this table structure, and you can always add more as well. So this is how empiricism works. Empiricism is a scientific method. So you state the claim clearly, and then it checks evidence for fact, interpretation, assumption, uncertainty, or speculation, and then what supports it, what assumptions are being made, and the confidence of these assumptions. Use this when the user asks for fact checking, analysis, debate prep, research organization, or public facing claims. Do not overstate evidence. Avoid these errors. And here is how you can add more biases. So you could have a whole file like on confirmation bias and fallacies. You can have a fallacy of a file that has all the fallacies, and you can have it check fallacies in any debate prep or ethical analysis. If you're analyzing something through an ethical lens, this makes it better. As you get better, it gets better. um so this proves when it only suggests. So why it fails: it overstates evidence. Avoid these errors. Everyone knows replaces evidence with social pressure. Obviously hides assumptions. Studies show without naming the evidence creates a fake authority. This always happens. Uses absolutism without proof. This never happens, uses absolutism without proof. It is clear that may hide uncertainty behind confidence. So it'll avoid these errors. These are common errors that most people will commit dozens of times every single day. Use precise language instead. Um, like instead of saying this proves, the stronger wording would be this supports, the available as evidence suggests, the reasoning appears to be. Specific evidence is needed here, often when supported, rarely when supported, or based on the available information, instead of generic claims like never, always, absolutely, obviously, stuff like that. Separate the facts from interpretations. So a statement, a video is uploaded on a specific date. Category fact, if verified. The video uses manipulative framing, interpretation. The creator intended harm, assumption, unless directly evidenced. The audience was harmed, requires evidence. This video may reinforce bias, interpretation, or hypothesis until proven. Do not convert interpretation into fact without evidence. So again, this is literally the scientific method for ethics and analysis and research. This will be your new best friend for learning logic and basically everything accurately. Obviously, you still have to fact check and whatnot, but this I can't stress enough how much this will literally boost your like it'll boost your personal knowledge tenfold like overnight. It'll make learning so much fun. You will love it, I swear. So here are some assumptions that it'll detect, some biases like a motive assumption, knowledge, group, causation, moral, normality, or majority assumptions. um, do not claim causation from correlation alone. Again, scientific method. There's correlation, plausible influence, supported causation, strong causation, and proven causation. When causation is uncertain, use may contribute to, is associated with, or could be a factor. Use confidence ratings when useful. So different confidence ratings based on what available evidence there is. Treat these categories as needing current verification. News, laws, medicine, finance, technology, politics, and platforms. When current accuracy matters, verify with up-to-date sources before making a firm claim. So this checks the internet for a claim and then gives it to you. So instead of just assuming right off the bat, it'll automatically search the web to make sure it has updated sources before making a firm claim, and then you can fact check that, and the sources will be more recent, so it's easier to fact check. Source quality, just like studies. Not all sources are equal. Use this source hierarchy when possible. So there's different types of sources. So there's a primary source, official documentation, peer-reviewed, reputable journalism, expert analysis, personal testimony, social media claims, and anonymous claims. Do not treat popularity as reliability. Again, scientific method. Ethical claims should not be pure vibes. When analyzing ethics, separate harm, evidence, consent, power, alternatives, consequences, and exceptions. And then there's also a falsifiability rule. If you're wanting to learn accurately, you typically want to base your life on what's falsifiable, and what that means is that it can either be proven true or not. So, for instance, religion isn't a falsifiability in a scientific method. You can't prove or disprove it, but there's no evidence to show that it does exist. So it'd be what evidence would prove this wrong, what evidence would weaken this, would strengthen this, what am I assuming? So it'll expose your own biases, and over time it'll show you your own assumptions, and this is how you learn how to debate your own points. And by debating your own points, you will get significantly better at general logic and reasoning. A claim cannot be questioned, should not be treated as empirically proven. So a claim that cannot be questioned should not be treated as empirically proven. Do not invent sources, quotes, statistics, dates, legal claims, medical platform, personal history, technical capabilities, file contents, or user intent. So this prevents it from This reduces the chances that it'll hallucinate, although hallucinations still happen. When information is missing, say what is missing. When the user provides a file, use the file. When the user provides text, analyze the text. When no evidence available, mark the answer as provisional. When helping make public content, use stronger evidence discipline. Before making a public claim, check accuracy, framing, attribution, risk, uncertainty, and evidence. Direct response pattern, direct answer, evidence status, what is known, what is uncertain, what conclusion is justified, what should be checked next when needed. So there go. We have two, and then the third file is going to be reasoning, recursive reasoning loop. This is the recursive engine that GPT will use to check things, to analyze recursively. Recursive reasoning means repeated refinement through structure. It does not mean circular reasoning, and it does not mean repeating the same answer. It means returning to a claim, problem, or output with better evidence, clear definitions, strong distinctions, and corrected assumptions. So every time it goes over a recursive loop, the problem gets that much more definitively solved to as much as it can be. So the more you recursively loop over something, the more definitive and a better response you're going to get. Okay. And then there's core definition. Recursion means returning to the problem with an improved structure. Recursive reasoning, ethics, and then circular reasoning, iteration, and refinement. So these are the definitions. So repeating a claim without independent support, repeating a process. Recursion is not repetition alone. It is repetition plus correction. So it goes over it multiple times, but every time it goes over it, it makes a correction. So imagine you have a big problem, you go over it once, you fix one mistake here, then you go over it again, and then you fix another mistake, and you every time you're going through this cycle, it it makes a correction. So that's why this is not circular reasoning in that sense. It's recursive reasoning. So right here, it even defines the definition between recursion and circular reasoning. This is so that the AI doesn't confuse circular with recursion by giving it an example of what not to do. So recursive reasoning is it examines the claim, tests the original beliefs, searches for contradiction, requires external evidence or logical consistency, ends with a refined version, reduces bias, and moves upward like a spiral. Use this distinction whenever the user is accused of going in circles while they are actually refining an idea. And then right here we have the recursive loop, which is define, break down, evidence check, assumption check, consequence check, contradiction check, context check, refine, and then save. What reusable rules should be kept for future use? Do not skip the definition step. A vague claim creates a vague analysis. And yeah, it just goes on from there. It's going to be too long of a video if I go over it all the way. And then there's the correction log template. So use this file to track mistakes, corrections, and reusable rules. If you're using SQL via an API, then you don't have to do this. It can do it for you automatically. And how that works is basically it stores this into your SQL, your Postgre, or whatever on your computer, outside the browser, and into the API database. And then so it automatically does this. You don't have to add it to the file manually, but this is a surefire method without API for those that may be poor. Every useful correction should answer 4 questions: mistake, was it wrong, correct rule, and reuse trigger. So here's a correction log. So anytime you find a mistake, you document the mistake here with the correct rule and the reuse trigger. So the reuse trigger is something that triggers it to automatically happen. And then there's example corrections. ChatGPT gave a script when the user needed an attachable project file. Why it was wrong: the format did not match the user's actual need. Correct rule: when asked for project files, write direct reference documents, not narration. Reuse trigger: creating project files, templates, instructions, and docs. And you can even deactivate or activate. Yeah, this is a really amazing system. This will make learning GPT so much fun, so much better. Command sheet. This is where things get really cool, and you're going to be able to customize it right off the bat. So you can add your own commands here. You can just add another add some more lines here, and you can make it whatever you want. So you can make a single slash command do like a paragraph. So if you wanted to, you can make a paragraph under a command, so that you just type that one command and it executes a long string of a command of like a prompt. So it's basically like a macro, just like a game macro in like World of Warcraft or something. It's just like that. And so here's some of the default commands I've included. And there's like this goes over all specifically the commands, and see how each command I have the sub information. So this basically is the index. This is the index and the function. But as we go down here, it expands. So you could have evidence check be like a page long, and it would go through all of this information for that one command. So you can see, as you can see, this is amazing because this will save you dozens and dozens of hours. And then on 6, we have project memory method. Use this file as the project continuity method. The goal is to create a stable reasoning environment across multiple chats, files, examples, corrections, and commands. Think of this almost as some sort of persistence, not perfect persistence, but some continuity. Project memory is the effect created when a project contains repeated structure. That structure can come from project instructions, attached files, definitions, correction logs, command sheets, examples, repeated chats, and checklists. Use these sources to keep responses consistent. So the more you consistently use it, the better it becomes consistently, continually. So if you're constantly detecting a bias across multiple chats, it'll automatically check for that bias without you even updating the file. That's one of the beauties. That's one of the beautiful things about the continuity and how GPT dreams, quote unquote, which is an official feature, by the way. And then we have 7 here, which is a output checklist. So this gives you a checklist of the outputs. So the goal is to check whether an answer is ready to use. Do not treat this checklist as decoration. Apply it when the user asks for output check, when generating public-facing material, when creating project files, or when the task requires high accuracy. And this gives the entire like method of fact-checking scientifically using the empiricism, which is like which means empirical, as in factual, objective fact. So empirical science is basically like an objective fact, essentially, like as close to an objective fact as possible with evidence that supports it. And then there's the AI reasoning environment, and this file goes pretty long. But yeah, so now once we do this, we'll go into the browser and set this up. So if we go here, I got the sources here, and we'll go to chat. I'll just show initialize is usually how I start my projects. The initialize makes it go through all the sources and initialize everything. So so here we go. It's working. It's not my main system. My main system is amazing because it took 4 years to make. Um, but yeah, here we are. We have overgeneralization, binary thinking, group flattening, false certainty, missing accessibility context, moral flattening, tool absolutism, and neglect of systemic barriers. So AI does not help all disabled people equally, and it can even fail or even create risk depending on the tool, task, cost, privacy. But the blanket claim AI cannot help disabled people is too absolute. A far more accurate claim is AI can help some disabled people with specific tasks and barriers, but it should not be treated as a universal solution or replacement for real accessibility, healthcare accommodations, or support. When discussing disability in AI, do not treat disabled people as a monolith. Separate the person's need, the task, the tool, the evidence, the risk, and the system level barriers. So per person basis. So AI does not help every disabled person equally, but it can help some disabled people with specific barriers. Separate use cases: reading, writing, planning, communication, executive function. Um, which helps with executive dysfunction, accessibility support, research, and creative work. Use disabled people or people with disabilities and analyze needs by context rather than a single block. Ask what kind of disability, what task, what tool, what support, and what outcome is being judged. Frame AI as a possible accessibility aid, not a universal cure or replacement for support. Judge by harm, benefit, consent, access, reliability, and dependency, not by blanket approval or blanket rejection, aka absolutism. Specify the tool and the task before judging usefulness. So it treats AI as one thing. Different tools have different risks, quality levels, accessibility features, cost, privacy issues, and failure modes. This is factually wrong. Protein exists in many plant foods, including legumes, soy foods, nuts, seeds, whole grains, and some vegetables. Food Data Central is an official nutrient database for checking this directly. Um, some plant foods are lower in protein than some animal foods, but many plants contain meaningful protein. Not only that, but plant protein is better for you than meat protein. A varied plant-based diet can supply essential amino acids. Judge the total diet, not a single slogan. Replace the binary with which plant foods provide enough protein for this person's need. Plants do have protein. A more accurate statement is plant foods vary widely in protein content, and a well-planned plant-based diet can provide adequate protein, especially when it includes legumes, soy foods, nuts, seeds, whole grains, and varied protein sources. When analyzing nutritional claims, separate presence of a nutrient amount per serving, bioavailability, dietary variety, and individual needs. Do not turn measurable nutrition in question into an absolute slogan. So as you can see, it works. It can check bias, simple as that. So you don't even need something extremely complex with my system. It makes it really easy. This is perfect for the disabled. You can learn so much with just this, and if you subscribe and like, then I can make more tutorials. If you have any ideas you would like to see, let me know. I love helping the disabled.